Hello everyone, good afternoon. Welcome to today's webinar on Beyond Modeling, Driving the Next Generation of Product Design with Kompas3D. I'm Nagraj, working as a design engineer at Day Simulations. Some of you may already know about this software, but for some it might be completely new. Either way, I will give a practical overview of this software, like what it can do and what makes it different from other CAD software and where it can fit your engineering workflow. So before we dive into Kompas3D, let me introduce JCM Innovations. JCM was started in 2022 with a fairly simple objective that's helping Indian engineering companies to gain access to world-class engineering tools and technologies. We're also specialized in the turbo machinery domain, where we provide solutions for pumps, compressors, fans, steam turbines, and gas turbines. And we work for the industries like aerospace, energy, HVAC, and industrial machineries. We do also work on research and developments. And along with the engineering services, we also provide software solutions, which is related to CAD, CFD, and other simulation software. And Kompas3D is one of those solutions. That's what we are going to explore in today's session. And our work generally falls into three areas. First is our engineering services, where we support with product development, design analysis, turbo machinery engineering, and the heat exchanger designs and many more. Specialized engineering projects. And another important area is the software solutions, where we work with a wide range of engineering tools and we help organizations to identify and adopt the right solutions for their workflows. And apart from Compass 3D, we also work with the tools such as TurboTides, which is specifically designed for turbo machinery design, and Cycle Tempo for thermodynamic cycle analysis, and ANOVA CFD for open form pre and post processing, and many more FEA and CFD software. We also do a lot of trainings. We regularly conduct workshops, webinars on topics such as CFD, FEA, and other fundamental which is related to turbo machinery. So let's move on to today's topic and take a closer look at the Compass 3D. So Compass 3D is a mechanical CAD software which is developed by Ascon. They have been around since 1899. Like it's not a new software. They have been in the CAD industry for around more than 3 decades. And one thing I find particularly interesting is that Compass 3D doesn't depend on a third-party kernels, as they have their own geometry kernel, which is called C3D. We will discuss about that in a bit. So today, Kompas 3D is used by thousands of companies worldwide with over 80,000 installations. So this is not a new software in the market. It's a well-established CAD platform that's already in industry for like many years. Now, here in India, we are the authorized partners for Kompas 3D. So if you got any questions about the software or want to try it out, you can always reach out to us. Now let's look at some of the challenges which are faced by engineers in a day-to-day life. So one of the most common thing is the rising cost of the CAD software. So every year when when the time comes to renewal your CAD software, it seems like cost is going up every year, and it will be a great pain for like smaller companies, startups, and even growing engineering teams, that can be a real concern. And there are the day-to-day challenges like managing the design changes in large assemblies and handling multiple product variants and spending time on repetitive tasks that can be really automated and which saves a lot of time. And another interesting point is that many CAD platforms rely on third-party geometry CAD engines like kernels, which are basically you might heard of this Parasolid or ACIS. So since they don't own the main CAD engine, so they don't have complete control over the core modeling, uh, which in turn causes make uh, core problems like when uh, when bugs appears, it will take a lot of time to resolve those things. We'll see that in a moment why that actually matters and how Kompas3D approaches it differently. So these are basically some of the challenges which is faced by engineers today. So what makes Kompas3D actually stand out by solving these problems? So let me quickly walk through these things. First is the C3D kernel. Now, without getting too deep into it, the kernel is basically the core engine behind a CAD system, and that's what makes the Compass 3D different. As the Ascon owns C3D and develops its own kernel instead of relying on a third party. Like let's say you're using a CAD system that's built on a third party kernel like Parasolid. If software company finds any a bug or they want to introduce a new feature, they may have to depend on the kernel provider to make certain changes. So now, let's say we find a we have to add a new feature in Compass 3D. So as Ascon owns the C3D kernel themselves, so they have much control over the development process. So if they want to add a new feature or improve something, they can direct they can work directly without waiting for other third-party kernels to do it. So that helps them to move faster when it comes to new feature and bug fixes and with overall product development. And second thing is that it composite is mainly built with a manufacturing things in mind. Like before creating this software, they had a lot of thought into like how it can be fit into a manufacturing industry instead of a generalist CAD software, and how assemblies are managed, how information flows from design to production. Like if your design eventually, basically manufacturing designs end up on shop floors, and this becomes the very important thing where you need manufacturing abilities in a CAD software. And third point is cost. This is one of the reasons many companies start looking at us in the first place. Like Composite offers a full-featured professional CAD environment at much lower cost compared to many of the well-known alternatives. And one more is the automation and customization. Let's say you're creating some designs and you need to create the same design again and again. So if you want to do that, it will consume a lot of time, and there is no automation. So in Compass 3D, we have that feature called API connections, where we can automate every process in the software, and it will basically improve the productivity of the team, and it's basically a game changer for a components.
And finally, it's a local support. Since we are the authorized partner in India, so customers have access to local training, technical support, guidance whenever you need it. Like we'll provide from starting from initial consultation to technical support with user training and all. We will be there till the end. Now let's look at some core capabilities of Kompas 3D. First is parametric modeling. If a design requirement changes, you simply update the parameters and the model updates accordingly. That's something engineers rely on every day. And in Kompas 3D, we have that feature built really well. And Compass also supports large and complex assemblies, whether you're working on industrial machinery, automotive components, heavy equipment, manufacturing, or any other mechanical engineering product with multiple components. In Compass 3D, it's easy to manage the relationship between parts and keep everything organized. Another feature really like is the automatic link between the 3D models in the 2D drawings. So as you see here, whenever you update in a drawing, it will not link with the 3D model. But in Compass 3D, we have that feature where it will it will link with the 3D model. So whenever you make a design change, it will automatically update. Whenever you make a design change in the 3D model, so it will automatically get updated in the drawing. So you need not to again update in the drawing. So this basically time saves the more time. And next thing is the flexible design tree, which is well organized, which makes navigating complex models much easier. So with the structured tree, you can access all the sketches, planes, solids, construction geometries, or uh, like in a uniform way. And it also has a timeline-based tree where you can go back to any stage of the model and you can edit and you can come back. Now, these two features are particularly useful. Let's say that are like variant and version control. Let's say you're designing an impeller and you want to create five, six, or seven blade configurations. Now, in Compass 3D, instead of creating three separate models for three separate blade configurations, you can create multiple variants from a single file and you can switch between them easily. That makes design exploration much faster and easier to manage. And also, when it comes to version control, it's also equally important. Like as the design evolves, it can always track the revisions and compare versions. And if you want to go back to the earlier designs, if needed, you can always go back to the earlier designs. It helps team to stay organized. It helps to prevent the approved design from being overwritten accidentally. And you will also find this feature called change phase position, which is useful when you need to make a quick modifications without rebuilding the geometry. Especially when you import some uh, other step or IGS files. So you need to modify some of the faces or some of the you need to move some of the faces. So at that time, this feature will really help by giving access to move the faces or change the face position without even editing the sketch or without even creating from the scratch. And for reverse engineering, Compass 3D can take the scan data and turn into something you can actually work within CAD. Uh, like it also has a tools that help you pick out features and rebuild parts directly from the scan models or mesh like STL files. So which makes the process a lot easier. So it has like you can you just have to uh, specify the select the mesh faces, so it will automatically detect the shape of that selected face, whether it's a plane or it's a circular or it's a cone. It will automatically detect and create surfaces, and you can use the surface features like surface trimming and surface extrusion to trim and make it as a solid model. So it's like a main main feature which uh, which is powerfully working in Kompas 3D. Another common question is that file compatibility. Like Kompas 3D supports like major industry formats. Like it can export to all these standard models like Parasolid, ACIS, STL, STEP, and IGS, JT, and even C3D. So it makes much easier to exchange data with the customers, suppliers, and other CAD systems. And this software also supports common engineering standards like ISO, DIN, ASME, and it will give access to the standard components like parts, pipelines, like all the common standard parts. So it will make a design can where you can design inside the software so without being create creating the new file for the parts. And finally, access control feature. This feature helps teams to manage like who can view or modify models, where you can set passwords and give access whether they have to edit or they have to just read the model. So it becomes important as project grow and when it involves a lot more people. So so far we looked at the core CAD capabilities. Now, but behind modeling, Compass 3D also includes a number of specialized engineering models that actually extend its capabilities into analysis, simulation, and design automations. So let's go through some of them. First, under mechanical design extensions, Compass 3D includes the dedicated tools that help you to create not just part assembly drawing fragments. It also helps you to create steels such as pipelines and advanced sheet metal modeling. And when it comes to analysis and simulations, it has dedicated modules for FEM that allows you to run FEM simulations inside the software itself. So this can be performed inside the uh, it can be performed for all the models within the software and without you don't have to export the model or do it in a separate software. So it will help you to minimize the CAD export errors and other surface errors. And another useful model is the mechanical springs. So if your design involves a spring and the software can help to generate and define the spring geometry based on the parameters and based on what type of springs you need, and based on your requirement. Uh, so this reduces the manual modeling effort, like creating from scratch, like creating a spring from scratch is like a really a like based on the parameters like the force, how much force it has to withstand, and how much what should be the output, uh, what should be the like whether it's require meeting our requirements or not. So it becomes a crucial parameters. So we have the dedicated add-on for Spring to create the Spring models easily. Now, it also has a shafts gears, which where it can create the shafts gears, which is like if you're working on a like gearbox or rotating equipment design, oh, it becomes crucial to like designing the gears or shaft from scratch is like really headache. So in Kompas3D, you just have to enter the design parameters, and the software automatically generates the shaft and gear geometries along with the 2D drawings. And next is the Compass Flow, which is basically for a CFD and thermal analysis. So, like if you are working with the fluid systems, thermal management, or cooling systems, other general product performance. So this module allows you to perform CFD and thermal simulations directly within the software. Now, animation. This feature allows you to create motion and kinematic simulations of the assemblies, which will help you to check the movement of the assembly and to identify any interference issues are there, and to demonstrate how the mechanism actually works. And next is the libraries and components. Instead of modeling common parts from scratch every time, you can quickly access the standard machine elements like fasteners, bearings, flanges, and other commonly used components directly from the library. And next is the productivity tools. So one example here is comport is support for custom macros. Like if there are repetitive tasks that engineers perform regularly, those tasks can be automated, and it will help to improve the productivity and maintain consistency across the projects. So for companies looking to bring more engineering work in house, this modules provide capabilities that go far behind traditional modeling. So this covers the presentation parts. So let's move on to the software for a quick demo on how to create a fan bond propeller blade. And let's look into some useful features and the interface of the Kompas3D. So now I launch the software and select the part. So as I'm creating a part model, and now here you will get navigation bar with all the modules and the tools which is available for basic modeling, which are solid modeling, surfaces, sketch tools, and you can do the sheet modelings and all the other things are there, like Compass Flow, APM, all under one column. And you also have quick sketch parameter pan where you can directly create the features like lines, circles, and all other sketches easily. And you have uh, feature elements of a solid where you can extrude the elements and can give a thickness of a surface and you can create a rips and all other basic which is required for the manufacturing when you are designing a manufacturing model. So let's create one propeller blade. For that, first let me create one hub and I will show how to create. So first we need to select one plane. So I'll select this plane and I'll right click and start sketching. Now I'll just create a circle, the radius of 25 to now I will exit this sketch and select the extrusion. As I am creating the blade, I will just use symmetrically option where it can distribute equally among the full surface. So I'll just specify it as a thickness is of 15 and it has created the above the propeller blade. Now I'll just import a 2D 2D profile 2D airfoil data. So in order to import the 2D profile data and create a loft, I created one macro where it can automatically import the 2D coordinate data and create the lofted wing or propeller blades. So in order to access that, in order to access macros, so you just go to the compass macro and click macros here. Here you can add, change, or let me edit this. I will show how the code looks like. So this is the code which was written specifically to import the 2D profile and create a blade from it. I'll just close and now I will just run the macro. I'll just select that macro and I'll click run. Now it has successfully imported. Now it will ask to select the airfoil file. So it has already selected. So if you want to select again, so it will show this pop-up where you can select the 2D text or dat file and it will import the coordinates and so now it has successfully imported a coordinate. In order to view that, so we have to rebuild the model. So in order to rebuild, either you can click here or you can just press F5. So as you can see, it has created the lofted model of the fan, and you can always edit the parameters. So this macro is built in such a way that you can edit the parameters in the variables panel. So it will be easier for you to control a full blade within the table. No need to like editing every in it, no need to edit the sketches in every plane. So with this feature, you can just like let's say instead of 5 blade profiles, I want like 10. So if you just enter and click F5 or rebuild, it will automatically create the 10 profiles and which is basically around the 200 mm. So I will use this for this model. Uh, Now, like if I want to change the angle of this blade, I can always control it here. Or if I want to change the chord of the uh, profile, 2D profile, I can always manage it here. So let's say I will take 20 and click F5. It will automatically regenerate the airfoil and you can specify for
each work plane separately. So now it has created the full model. And if you want to hide the all construction geometries, so you can just switch to structural representation and you can just hide it. So now you can see the full blade. Now, before creating the variants, let's see how to create versions. Like I need I need two models for analysis. Like the length should be the blade length should be like 200 for one and like 100 for another. So as this blade length is 200, so let me create another version. So in order to create version, I will go to tree, and then here we have option to create versions. So if I click on this, it will show the version number, and you can always edit these parameters, and you can name the part also. And like if the version you are creating, if you want it to be dependent on the previous version, you can click this. If you don't want it, you can just turn it off. For now, I will turn this option off. So now I click. Now it has created the second version of the same model. So here you have access to edit all the parameters. So if I want to change the diameter, I'll change like so I'll just give 20. See, it has changed without affecting the other model. If I switch back to the previous version one, it doesn't affect at the version one. The changes were made only to the version two. So this is how the version control and this feature works. So like let's say I want to change the uh, chord length of this blade or angle of this blade. So first I want to change the length of this blade to like let's say one uh, one- 100. So I will just give 5 and when you press F5 then it will automatically generate the profile. Now I want to change the chord value to I'll just specify this 15. Then I'll click generate. See now it has created the two versions with two different configurations, like one with the different up diameter and the blade length. And now I will switch back to the previous version. Here, let's say I want, let's complete the blade first. So I'll go back to the solid modeling. Now I will use array by concentric grid option to make the replicas of the blade. So I will just select the y-axis, which is the rotation axis. Now, so I'll leave it as 4, then I'll create. Now it has created the 4 blades. And now, as you can see in the structured view, it has two separate solid. Up is not attached to the blade. So in order to attach both, we can use the Boolean operation where you can select both the solid components and merge it. See, now it has created the single solid model for full blade. Now, let's create variants. Like I want two two blades. Now we have 4 blades, but I want 2 blades, 3 blades configuration also. So in order to create that, I don't have to create one more file. So I can just go back to the versions, and here I have option to create a variant. Variants are always like they are dependent on the uh, parent model, so you can't disable that option for the variant. So let's say I'll name it as a two-blade configuration, and now it has created that version. Now, if I want to change the to two blades, by default, all the parameters are linked with the master model. So I just have to make it as a two blade. So I will just edit this, cancel the link first, and then I will get access to edit this. So here I can specify it as two. Then I will flip. So it has like it just uh, made the number of blades to two without making any changes to the full model. So with this variants feature, you can actually create so as many variants you want. Let's say if you want to create one more variant with three blade, you can always create from the master model. So the same procedure follows. As you can see, it has created three blade and two blade configurations, which is dependent on the master model, which is the version 1. So now, let's say if you make any changes to the version 1, like you will change the, let's say you will make a, you will change the exclusion element value. Let's say we'll change the length of the up to 20. So it will automatically update over all the versions you have created. It just need a rebuild, then it will automatically update. So like this in Kompas3D, we can create models, and we can use the automated scripts to import the profiles, and you can do a lot more things in Kompas3D by using macros, and you can make a use of these features like versions and variants like this way. So now uh, that's it for the demo. Uh, so like that that's what I wanted to cover today. So I hope this session has given you a good overview of the Compass 3D and some of the things it can do. So if you'd like to learn more or try the softwares or discuss any specific requirements, feel free to get in touch with us. If you have any questions, you can just drop us a mail or in the chat. So thanks everyone for joining. I really appreciate your time. Have a great day.